Hello students, hope you are doing well. In this video, we are going to discuss routing of Unit 5, designing IP addressing in the network and selecting routing protocol for the subject Enterprise Network Design of B7 semester IT University of Mumbai. In this lecture, we will discuss routing, fundamentals of routing. This is add-on lecture for the subject Enterprise Network Design. It is not in your syllabus, but to recall something, I had added this topic in your series. So what is the router? Router is a process of selecting path along which the data can be transferred from source to destination. Okay, from source to destination. So this is the strategy to find the path from source to destination. Then it is known as router. Routing is performed by a special device known as router. Router is that device which perform routing. A router works at network layer. It works at network layer in the OSI model and internet layer in the TCP/IP model. Internet layer in TCP/IP. This is in OSI and this is in TCP/IP. A router is a networking device that forwards the packet based on the information available. So the router is networking device which transfer packets or forward the packet based on information available in the packet header and the forwarding table. Okay, the routing algorithms are used for routing the packets. So the routing algorithms are nothing but a software responsible for deciding the optimal route. Okay, so for router, routing algorithms are there, and it is a software that decides the optimal path. Fine, through which packet can be transmitted. So through which packet can be transmitted. The routing protocol are used to metric. Actually, the routing protocol use the metric to determine best path. For this, we use metric. There are different metric available. We will discuss in next slide. The metric is a standard of measurement such as hop count, bandwidth, delay count, current load on the path, etc. used by the routing algorithm to determine optimal path to the destination. The routing algorithm initializes and maintains the routing table. So the heart of this is a routing table. Routing table. Okay. For the process of path determination, routing metric and costs are used for determining the best route to the destination. The factors used by the protocol to determine the shortest path, these factors are known as metric. Okay, so these factors are known as metric. In routing, it is associated with routing metrics and costs. Metrics are network variable used to determine the best route to the destination. Best route to determine the best route to the destination. For some protocol use the static metrics, means that their value cannot be changed, and for some routing protocol it uses dynamic metrics. It means that their value can be assigned by the system administrator. Fine. So first metric is hop count. If we want to determine the path, suppose these are the intermediate nodes. So how many number of hops are there to find a path from P to Q? Okay. So from this place to this place, this is known as one hop. And likewise, if multiple adjacent nodes are there, to traverse how many number of jumps it needs to take. Hop count is defined as the metric that specifies the number of passes through internetworking device such as a router, number of passes. Okay, this is also number of passes. Through internetworking devices such as router, a packet must travel in a route to move from source to the destination. If the routing protocol considered the hop as primary metric, then the path with least hop count, least hop count is the will be the it will be considered as the best path to move from source to destination. Now come to delay. Delay should be minimum. It is the time taken by the router to process, queue, and transmit a datagram to an interface. The protocol uses the metric to determine the delay value for all the links along the path end to end. The path having the lowest delay value will be considered as the best path, regardless of number of passes or number of hops. It might be possible that number of passes is 5 and number of passes is 10. Okay. To use this number of hop count 5, it requires 30 millisecond, and for this 10 it requires 5 millisecond. Okay, so better or optimal path is this, with 10 number of hop counts and with 5 millisecond delay. Bandwidth is the capacity of link. Okay, the bandwidth is measured in terms of bit per second. Bit per second. Fine. The link that has higher transfer rate, like gigabit, is preferred over the link that has lower capacity, like 56 kb. The protocol will determine the bandwidth capacity for all the links along the path. The overall higher bandwidth will be considered as best route. Now come to load. It refers to the degree to which network resources such as router or network link is busy. A router or network link is busy. A load can be calculated in a variety of ways such as CPU utilization and packet process per second, packet process per second. Okay. If the traffic increases, then the load value will also be increased. The load value changes with respect to the change in the traffic. Now come to reliability. Reliability is a metric factor may be composed of fixed value. It depends on the network link and its value is measured dynamically. Some network go down more often than others. After each network failure, some network links require more easily. It repaired more easily than other network link. Any reliability factor can be considered for the assignment of reliability ratings, which are generally numeric value assigned by the system administrator. Okay, so this is actually qualitative metrics, and the qualitative metric is how much the particular link is with special quality, like repairment of link, etc. Based on this, some rating is provided by the system administrator, and based on this we will decide which route is optimal. Now come to different types of routing. So there are three types of routing: static routing, default routing, and dynamic routing. In case of static routing, it is also known as non-adaptive routing. Non-adaptive routing. It is a technique in which the administrator manually adds the link or a route in routing table. A router can send the packet for the destination along the route defined by the administrator. In this technique, routing decisions are not made based on condition or topology of the network. There are certain advantages of static routing. First is no overhead. No overhead because already we have decided what are the nodes through which we need to establish a path. So there is no use of CPU. Okay, it has no overhead on the CPU users of on the router. Therefore, the cheaper router can be used to obtain the static routing. Then bandwidth. Bandwidth is defined. It is not bandwidth uses between the router and the security parameter because already administrator had decided the fixed path. That's why the security is very good. It provides security as the system administrator is allowed only to have control over the routing to a particular network. But there are certain disadvantages, like for a larger network. For a smaller network, it is okay. For a larger network, it becomes very difficult to add each route manually to the routing table. The system administrator should have good knowledge of topology as he has to add each route manually. Then come to default routing. This is non-adaptive and defined by the system administrator. Default routing is a technique in which router is configured to send all the packets to the same host devices, and it doesn't matter whether it belongs to particular network or not. A packet is transmitted to a device for which it is configured in default routing. Actually, it is more or less a static kind of routing. Default routing is used when network deal with the single exit point. It is also useful when bulk of transmission networks have to transmit the data to the same hop devices. When a specific route is mentioned in the routing table, the router will choose the specific route rather than the default route. The default route is chosen only when a specific route is not mentioned in the routing table. Now come to dynamic routing. It is known as adaptive routing. It is a technique in which router adds a new route in the routing table for each packet in response to change in the condition or topology. Okay, so it is responsive for change also. Whenever topology is changing, it will automatically add the route. Dynamic protocol are used to discover new routes to each to reach the destination. In dynamic routing, RIP and OSPF are the protocol used to discover the new routes. If any route goes down, then automatic adjustment will be made to reach the destination. The dynamic protocol should have different features, like all the routers must have the same dynamic routing protocol in order to exchange the route. Okay, so same protocol must be followed. If the router discovery any changes in the condition or topology, any changes in the condition or topology, then router broadcasts this information. It will broadcast this information to all other routers. Advantages of this are easier to configure, and it is more effective in selecting the best route in response to change in the topology, condition or topology. Disadvantage, it is more expensive in terms of CPU and bandwidth. It is less secure as compared to default and static routing. Okay, so with this we finish introduction to routing protocol. In this lecture we have covered routing protocol and its introduction and matrix used for describing the routing. In next lecture we will discuss protocol features associated with routing. Thank you very much. Bye bye for now. Have a nice day. Have a nice time.